In section 7.1, we're going to talk about finding square roots. Here are your definitions from this chapter. A square root of a number is a number that, when multiplied by itself, equals the given number. Every positive number has a positive and a negative square root. The second vocab word is a perfect square. A perfect square is a number with integers as its squared root. Now we're going to start talking about squared root. First thing I want to talk about, though, is the perfect square. If I just ask you about this, the square root of 25. The square root of 25 is asking you what number times itself gives you 25. It'd be 5. But the square roots of 25 could also be negative 5, because negative 5 times negative 5 is also 25. So 25 is a perfect square because 5 and negative 5 are both integers. Remember, integers are just positive and negative whole numbers. Whole numbers and their opposites. So I'm going to write down over here perfect squares. So for example, 2 times 2 is 4, so 4 is a perfect square. 3 times 3 is 9, that's a perfect square. 4 times 4 is 16, that's a perfect square. 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9, 10 times 10, 4, 9, 16, and on. All of these numbers here are perfect squares because they have integers as their squared roots. Example number 1. Find 2 square roots of 49. What number times itself gives you 49? Well, 7 times 7 gives you 49, or negative 7 times negative 7 is 49. So your 2 square roots would be 7 or negative 7. The square root symbol is called a radical sign. There's a vocab word. It is used to represent a square root. The number underneath the sign is called the radicand. So for example, if you are just given a square root, that's going to be a positive square root. So for example, the square root of 16 is just going to give you 4. A negative squared root is going to be a negative on the outside. So for example, negative square root of 16 will give you negative 4. Both positive and negative square roots would look like this. Positive and negative. So, for example, positive and negative square root of 16 would be positive and negative 4. So let's do some examples. Number 2, the square root of 25. That's just what number times itself gives you 25, and since it's just the square root, it's positive. That gives you 5. Number 3, the negative square root of 9/16. Well, we know it's going to be negative. And now what number times itself gives you 9/16? Well, what number times itself gives you 9? It'd be 3. What number times itself gives you 16? It'd be 4. So your answer is negative 3/4. Number 4, positive and negative square root of 2.25. So 2 and 25 hundredths. Take the square root of it. It's going to be positive and negative 1.5. So if I asked you, for example, number 5, the negative square root of 1. What number times itself gives you 1? It'd just be 1 and the negative comes down. So your answer is negative 1. Number 6, what's the square root of 400? What number times itself gives you 400? It'd just be 20. Number 7, positive negative square root of 4/25. What fraction times itself gives you 4/25? It'd be positive and negative 2/5. The next section, we are going to evaluate each expression. So what we're going to do is take the expression and just simplify it. So in 8a, 5 times the square root of 36 plus 7. Well, 5, and then we know the square root of 36 is 6, plus 7, and then 5 times 6 is 30, plus 7 would be 37. Super easy. Example B, 1/4 plus the squared root of 18/2. Well, first off, we can take 1/4 plus the square root of 18/2. 18 divided by 2 is 9, so that'd be the square root of 9. The square root of 9 is 3, so 3 plus 1/4 would be 3 1/4. C, the squared root of 81 squared. Now here's something new. You will notice that a squared and a squared root, they are inverse operations of each other. Therefore, they cancel each other out. The squared root of 81 squared is just 81. That's it. So in C, we're going to have the square root of 81 squared minus 5. So really, this is just 81 minus 5, which gives us 76. Now to prove that, here's how it works. The square root of 81 is just 9. And then the squared comes down. But 9 squared is 81. So therefore, you can just skip that step and go right to 81. So once again, the squared root and a squared cancel each other out. So 81 minus 5 gives you 76. Example number 9. The area of a crop circle is 42,216 square feet. What is the radius of the crop circle? First off, this is just a simple area problem. We know it's a circle, and the area of a circle, the formula, which you should know from 6th or 7th grade, is A equals pi r squared. A is area, r is squared. So all we know is this. The area is 42,216, so that gets plugged in for the area. 42,216 equals, and then pi is 3.14, so 3.14 r squared. Solve just a simple equation. The opposite of times 3.14 is divide by 3.14. 42,216 divided by 3.14 is 14,400. 3.14 divided by itself is just 1, so we're left with r squared. Now, this is new. In order to get rid of a squared, once again, a squared and a squared root, a square and a squared root are exact opposites of each other. So to get rid of this square, you take the square root of both sides. So that gives us r equals, and the square root of 14,400 is about, or approximately, 120 feet. Our last example, number 10, we're going to do the same thing. The area of a circle is 2,826 square feet. Write and solve an equation to find the radius of the circle. Once again, we know the area of a circle is A equals pi r squared. We know the area is 2,826, so that gets plugged in for the letter A, because that represents area. So we get 2,826 equals pi, which is 3.14, radius squared. I divide both sides by 3.14. 2,826 divided by 3.14, 900 equals r squared. We have to get rid of the square, so we take the square root. The square root of 900 is 30. So we know the radius is 30 feet.